folks? How's it going? This is Cargo here. Uh, I'm gonna be working on some operating system stuff today. So there's this operating system, very simple operating system called XV6, and I have an assignment for it to um, essentially well, the first part is to add an an additional scheduling algorithm essentially for processes. Um, and then the second part is to add priority for those scheduling processes. Um, so I'm not really sure how involved this is going to be yet. I've taken some like very brief looks at it and made some very basic code changes. But yeah, honestly, with that, let's just get into it. We'll see how it goes, and we'll go from there. Okay, so we have an OS. I'm not gonna bore you with the details of like how it's implemented and whatnot. Oh my god, my hair is a mess. That's what I get for waking up and not doing anything with my hair. But yeah, essentially, so we have a README here. So in this lab, ignore the threading part for now. Let's focus on the scheduling part. So, um, in this file proc.c, we have a scheduler function, which will basically, well, every CPU in our machine will eventually lead to this function. So here I can show you guys that. Oh shit, I accidentally closed the file. Oh well, probably wasn't important. But yeah, so here. So kernel source proc. So this file, so you can see here we have, if I scroll down far enough, so we have scheduler, right? So what this function does is it's going to be run by every single CPU or every single processor, and it basically dictates which process is going to run next on the CPU. So if we take a quick look at the code here, so you can see here we have a processor, we have a CPU. Oh, this is the processor pointer, CPU pointer. The CPU pointer is never going to be changed here. The processor pointer will be changed. And so essentially, so we have this for loop that goes forever, right? And what we're doing on every iteration of this for loop is we have a process table. So this particular operating system has a maximum of 64 processes that can be running at any time. So here you can see we have p table proc, and this proc table is only 64 whatever, struct proc size wide. So essentially, out of these 64 processors, we are going to find one that's runnable, and then we're going to put it on the processor. We're going to do what's called a context switch event, essentially, where we kind of trade out all of our cached data, kind of, for a lack of a more technical description. So yeah, essentially, that is all that really happens here. So we do our whole switching thing, and then here we're going to, so the switch.s, if we go to the definition, oh sorry, we need to, I need to find this file. This file is probably, no. Oh, here it is. So what do we actually do when we're like switching processors? Like we're just gonna we switch stacks. So each process, right, has its own stack, its own like data and stuff that it's saved during its whatever function it's been calling or something like that. So the idea is that you can pull a process off of the CPU during its execution, like in the middle of something that's executing, go do something else, finish that, come back, and all you can just kind of basically just replace the data back, quote unquote, where it was. Again, for lack of a better technical explanation. So that's all that's happening. This is x86 assembly for those that are kind of like new to this, but yeah, I mean, like the comments tell you everything that's happening here. You save the registers, you switch stacks, and you load the new registers. So you're restoring the state of the process before you paused it, before you paused the execution. So that's kind of what's going on there. And then yeah, we're gonna do this whole switching thing, and then we're going to basically run the process. Eventually, our process is going to exit out of this. I believe it's this switch KVM function. Okay, maybe I might have lied. Maybe I lied to you. Oh no, sorry. So switch KVM is what's actually going to put us back in kernel mode, I think. So in that case, so then shit, why did I close it? That's stupid. Okay, so this is gonna return. And then yeah, essentially so the process will continue running until it's either interrupted or finishes, or there's some other end cases where we would give up control of the processor to another process, but those are the two main ones. It's either interrupted or it finishes. So this operating system right now only has one scheduling I guess algorithm, or just one scheduling shoot, what do we call it? A scheduling policy, that's what it's called. So the only scheduling policy that we have right now is called round robin. You might have heard of it, but essentially what happens here is we're going to look through. We're basically like we're passing through the whole process table, and then every time we find a runnable process, we go there. So what happens, right, is like, okay, so let me pull up the paint document, right? So we have our process table, and then within the process table, let's say we have 4 slots in our process table, right? So, and then we'll say that process 1, 2, and 4 are runnable, and then maybe this one is not runnable, right? So we're gonna start from this side and move this way. So let's start right here. So this process is runnable, right? So we'll run it, all right? And then once this process exits, for one reason or another, we're gonna come here to the next process. We're gonna check, okay, is it runnable? Yes, it's runnable. We're gonna run it. We'll come out here and we'll see, okay, is this process runnable? It's not, right? We're gonna continue here. Is this process runnable? Yes, we'll run it. And then we're gonna basically come all the way back to the first process again. So how that's implemented here is we have this larger for loop, right? The whole thing. And then within that, here we have a for loop that actually goes through the entire process table. So we start at just the basically the pointer to the beginning of the 64 process array, right? And we're going to, on every iteration, we're going to add one process pointer to it. So basically iterate by one process. And every time that we find a runnable process, so you can see here we have this if p state is not runnable, then continue. So don't schedule it. But otherwise, we are going to schedule it. So yeah, so this will kind of continue until we reach the end of the process table, and then all we do here is we release the p table lock, and then the for loop starts again. We enable interrupts again. We acquire the p table lock, and then we start the whole process over again. So it's pretty straightforward for the most part there. Uzer, hello, how's it going? Hey, welcome. I'm talking about operating systems. I have an operating system project, so I'm just talking about how it schedules processes, if that means anything to you. You're doing good. Glad to hear. Man, I really liked the bowling ball video that you posted. Here, let me show you guys what Uzer posted earlier today. Where is it? There's a way I can open this not here, right? Isn't there like open original? Open link. Here we go. Oh, it just downloads it. That's fine. And then let me pause the music real quick. Oh my gosh, it's beautiful. It's amazing. I love it. I love it so much. Oh my gosh. I won't lie, I know nothing about software. Hey, you know what? It'd be like that. It's all good. This is actually okay, honestly, so I'm streaming in the software category. I'm aware of that, but this is not what I would consider software, what I'm working on right now. I don't know. It's kind of like I guess the easiest way to explain it is like you wouldn't consider like Windows as a software, or like Windows or Mac OS or Linux as a software necessarily, right? 'Cause I don't know. I kind of think of software as something that runs on Windows or runs on Mac OS or runs on Linux. But here I'm working on, essentially, the operating system, straight up. So yeah, it's not quite software, but I don't think there's a better category for it. So I'm making a base for software to run on. I'm not really making it. So this is an existing operating system. It's like a very, very simple operating system. I can actually, honestly, I can just show you what this looks like real quick. If I can remember. I think it was something like this. Oh shoot, do I not have it running? Hold on. But actually, wait, can I just? No, I probably have to build it or something. I'll show you in a sec. Anyways, but yeah, it kind of like you can just run programs or software on it. But it itself I would not actually consider to be software. But yeah, like what I was talking about just before you joined in, User, is essentially Jay Harry, thank you so much for the follow. I think that's 200 actually. 200 followers? Woo! Fun. Thank you, Jay Harry. I appreciate it. And thank you for the hydrate. But yeah, essentially what I'm doing here is I need to make some modifications to the way that this operating system schedules processes. What that means in kind of a very basic sense is if I open Task Manager, um, I can come here and in my processes tab, I can see everything that's running on my computer, right? Um, and if you're like even like vaguely familiar with just computer specs, right? You'll know that CPUs have a certain amount of cores and a certain amount of threads, right? Which means that they really can't run more than 4 or 8 things simultaneously. In most, I mean, there's some like Threadripper kind of cases where they can run a lot more things at the same time, but um, like how do I have so many processes that are running at the same time? Like I have like 8 processes all running, um, quote unquote at the same time, but they can't actually be running at the same time. I don't have that many cores. I only have 6 cores. Here you can see I only got a 6-core processor. So that's kind of where the scheduling concept comes in, um, where it's like, okay, we're gonna run Microsoft Edge for. I mean, like this is on like the scale of like milliseconds or something like that. Um, is this the thing where it switches between the processes really fast? Yeah, exactly. Yeah, you got it. So it's on a really small scale. Like you and I would not really notice this. Um, like just looking at like Task Manager or something like that. So yeah, you totally got it. Um, but yeah, so that's kind of how this is actually happening. Um, here. Um, so that's what we're doing right here. So what this is doing right now. So this operating system is a little bit limited in the sense that it can only run 64 processes at a single time. So there's this process table which contains information about every single process running on the operating system, and it only has 64 slots essentially. Um, but there's really not that many people that have 64 cores or 64 threads to run this stuff on. So there's still a need to actually schedule processes, um, so that you make sure that like one process doesn't hog up all your resources. Um, so um, essentially the way you can do that is you can so what's implemented here is a round robin scheduling algorithm. So this is like a very fair way to distribute time. So in this case, we say like, okay, process 1, you can run for 100 milliseconds. And then at 100 milliseconds, we're like, okay, process 1, you're gonna get off. Process 2, are you ready to run? If you're ready to run, get on the processor. It's your turn to run for how much ever time. Maybe the process doesn't need to run for a full 100 milliseconds. Maybe it'll exit at like 50 milliseconds. And then like once it exits, you can be like, okay, process 3, let's go. And it'll keep going all the way until process 64. And then once it finishes with process 64, it just comes back to the beginning and starts with process 1 again. So, um, so yeah, the concept is pretty straightforward, right? But then making modifications is pretty tough. But you know how it is. But yeah, okay. So let's look back at our little assignment description. It's a case of easier said than done. Oh yeah, that's literally all of operating systems. At least it seems that way so far. My previous project, I'll spare you the details, but it took me a very long time to finish. And I was not very happy throughout the duration of said project. I ate something really garlicky before starting the stream, and the taste is still there. I'm not like mad because I'm kind of a fan of garlic, but it's like it's just anyway. It's like kind of like drying out my throat. I don't know how to explain it. But yeah, yada yada yada. Um, Okay, so what I need to do, sorry, I'm gonna look this up real quick. Most complicated thing I've ever done is turn a Raspberry Pi into a server or game emulator. I mean, that's pretty up there already. I feel like, um, I don't. There's a lot of people that haven't even heard of a Raspberry Pi, let alone like actually use one. So, I think you definitely got something going for you there. Um, I haven't done that much with Raspberry Pis actually. Um, okay, so essentially, what we're going to do is we're going to go into our proc.c file here, and somewhere at the bottom, we're going to, just for context here, I've already defined this function set scheduler, and what set scheduler is going to do is it's going to, where did I put this? Where did I put this? Aha! Wait, no. Where did I put this? Hold on. I'll find it. I'll find it, I promise. Oh, here it is. No, I lied. Where the hell did I put it? Is it here? Aha! Well, here it is. Okay. So, essentially, this is going to take in 3 ints. But you can see it probably better here. Here. Okay. So the first int is a process ID. This is just going to be some sort of indicator for which process we're talking about. The second int is going to be policy. So in this case, we have round robin implemented already. So that's the schedule RR. We also want to implement something called schedule FIFO. FIFO is the acronym stands for first in, first out. So essentially, the first process that we receive, we want to complete fully first. So we're not going to. So with round robin, how we were like stopping every like 100 milliseconds or something like that, and we're saying like, okay, process 1, your turn is done. Process 2, it's your turn now. Process 3, it's your turn now. Instead, we're gonna say, okay, process 1, take as long as you want, and then once you finish, or once you want to hand off control, then we'll send it to process 2. Hi, I have a stupid question. If I learn, okay, first of all, no stupid questions, but if I learn algorithms and data structures of Python, is it the same concepts with another language? Um, I think okay, so Pandak, I assume, and thank you for joining the stream, by the way. Pandak, I assume that that you're kind of getting started with programming, kind of, or maybe you're just trying to learn um, algorithms and data structures particularly. But in any case, I think Python is a very good language to start with. Oh, Pandak, thank you so much for the follow. I appreciate it. I think it's a really good language to start with, just because it kind of the way that it's written is very simple. To the point where sometimes the syntax will even read like English. But yeah, I mean, like Python has a lot of the same kind of functionalities that other languages do. So like I want to show you, I'll just open a new file here real quick. So in Python, for example, like how we can access something like a dictionary. A dictionary, or sometimes it's called like a hash map or a hash set or something like that, is essentially, it's like, oh, okay, I give you an input, like it can be like it can be a number, it could be a string or something like that, and then you give me an output. So if I say like let's say I wanted to like see like how many calories were in each food. So let's let's say I made a dictionary of food or something like that. So we'll say like let's call our dictionary DICT, and then like we use something called a key in order to get the value associated with the key. So if I want to find like how many calories eggs is, then maybe I type something like this, right? And this is all you have to do in Python in order to get the value out of this dictionary entry. Whereas in Java, um, everything is implemented as like a class. Um, and so whenever if you want to use a dictionary, first of all, I want to say they're called hash maps in Java. I think that's like the main class that people use. But you have to do something like um, okay, first of all, in the declaration, you have to use like it's like hash map, and then you have to use some generic types. So we have to say like, okay, I'm gonna map like strings to I don't know, integers or something like that. And so then I'm gonna say, oh, okay, dict equals new hash map. I don't know. This might not be correct syntax, but it's something like this. And then once you do that, then like in order to add a new like key value pair, you have to do something like dict dot add probably, and then like you have to like put the key eggs and then the value like I don't know, it's probably like 70 or something like that. Whereas with Python, it's literally like you can already have the dictionary, and then if you just do this, you just do this dict, quote eggs equals 70, and now you've added the key eggs with the value 70 to the dictionary. Like that's it. It's like super straightforward. So I think that's what's really nice with Python. You'll see this kind of like concept kind of repeated among other data types in Python. Yeah, I think it's hard to make a wrong decision with how to learn data structures and algorithms. There's a lot of languages that are good. Personally, I learned most of this stuff in using Java. The difference in syntax. Yeah, I mean, basically, like just like the way that Python is written is the difference in syntax only in syntax. Oh, not quite. I mean, there's gonna be a lot of differences in like how these things are implemented on the back end, but they will be equivalent, right? So what I mean to say is that like if I say like, okay, I want to add the key eggs to this dictionary with the key eggs to this hash map with the value 70, like I can do that in both situations. Like they functionally work the same way in Python or Java or whatever language. So you're not going to run into an issue there. It's just like what is like which type of syntax is more conducive to your learning. I think that's probably something that you have to kind of just like you can play around with it a little bit, figure it out for yourself. That might be a lot more straightforward. What I would might suggest you do is go to a website like LeetCode. That's here, I'll type it in chat. Let me find the, yeah, I mean you might already be familiar with it. But for anybody else here, it's leetcode.com. Like this. This website has a lot of like coding challenges, I guess, or coding problems. And so what you can do maybe is try one of the easier ones and try it in Java and then try it in Python. And see which one makes more sense to you, maybe. Because for me personally, I think I would have probably preferred to have initially learned in Python. But you might be different. Like everyone learns differently. So that's what I would say probably. Does that answer your question, Pandak? Hopefully. Hopefully I didn't just send you down a rabbit hole or something. Anyways, back to OS. So yeah, so we're gonna implement this set scheduler concept. So we have our process ID, we have the policy that we're implementing. So that's gonna be either round robin or FIFO, and then we have a priority. Let's not think about the priority right now. Let's just look at the policy. And so this is gonna be a per process policy, right? So we can have some processes that are round robin. We can have some that are FIFO. FIFO again was first in, first out. Essentially, when process 1 finishes, then we can schedule process 2. Versus with round robin, it was kind of like, okay, after 100 milliseconds, we're going to say process 1, your turn is done. Process 2, you can start, regardless of whether process 1 was actually fixed or not. Yes, thank you so much. Yeah, of course. Pandak, I hope your learning journey here goes well with the algorithms and data structures. Yeah, best of luck. Let me know how that goes. My God, I don't know. My throat is super fucked. Anyways, so let's try to implement something like this. So first, just the setting scheduler thing. So what I assume we have to do here is we probably have to set some sort of I don't know. There's a few different ways actually that we can do this. One thing I'm thinking is one thing I'm thinking is like, so you see how we have this the like struct proc. So I can go to the definition of struct proc, right down here, and I can to this struct I can add a field for the scheduling algorithm, like what the policy is, the scheduling policy is, and I can add a field for the priority. So that's one option. The other option is to just create some separate tables. So again, it would be like 64 tables, and we would use the process ID in order to access those table entries essentially. Right now I'm leaning towards just putting that field in the process struct, honestly. I think that's probably the better way to go about that. Okay, other thing I'm wondering about is... Sorry, I'm like looking for something that I can't find. Oh, what isn't here? Okay, I was just scrolling down too far. Where did that go? Scheduler. Okay. So here in like the scheduler, like we get the full process, like we get the process pointer from the process table. So I don't know if we can like I don't know how we can actually let me see where this is. Oh, this is just up here. Let me see where all, like, everywhere this is referenced. So basically what I'm thinking about right now is how do we actually index into this array because I want to say you index using the process ID, but I don't know if that's actually true. Okay, it looks like we don't actually index anywhere here. It just kind of add and move on. So I'm hesitant to actually use the PID in order to index into that table. Oh wait, here let's see how PID is actually actually assigned, I guess. So when we create a new process, which is an allocate process. Okay. So it literally just it takes next PID, gives it to this process, and then adds one to that. So that won't work. That is not what we want to do. It's not what we want to use in order to index into that. So in that case, is this defined anywhere else? Is this referenced anywhere else? Or is it just in this file? I mean, that's fine. I have access to it in here. Anyways. Yeah. Okay. So yeah, honestly in that case, so let's define our function, right? So here we can see it's supposed to be int set scheduler. So we have these three arguments to this function. And so I guess I wonder if there's an existing function that can get me a process based on the PID. Let me look real quick. That would be nice actually. If not, we can just do a for loop through the whole process table until we find the one that has that PID. That's also fine. Okay, yeah. So see, so they're literally just they just scan through the table actually. Like they do this very often in a lot of functions. Like look at this. They do it again here. They do it here. Probably do it other places too. Yeah, they do it up here. If I just highlight this, I think I can actually probably see everywhere. Oh, never mind. I thought that would work. I guess it didn't. But yeah, I mean, anyways. So I think we can probably do something similar to this, where we basically just search for the process that has the PID we're looking for. So we can say like, okay, so oh wait, here, so we need to do struct proc, and that's gonna be a pointer. So we do something like that, right? And so we start it at the beginning of the process table, and we're gonna go all the way to the end. And in here, we're basically gonna say, okay, so if p.pid is equal to the PID we're looking for, which is this PID, our parameter, our argument to this function, right? So if those PIDs are equal, then we want to, in here we want to set the scheduling policy. Set scheduling policy, and then we also want to set priority, and that's literally gonna just be setting. I think that's literally just gonna be setting, setting them in the process. Like that's what I was saying, right? So like in here in process.h, like I think I can literally just say, like, okay, we're gonna have int policy, right? Or I can say like, I can even say like scheduling. That's kind of long, but it's okay. It is pretty descriptive. And then we can say scheduling policy. And then we can say int priority. And then that's going to be, as you guessed, probably scheduling priority. So, yeah, pretty straightforward there. So we'll just add those two fields here, and then we can go back to proc.c, and we can literally just say p dot policy, right? And we're just gonna set that to our policy, and then here we're gonna say p dot priority. We're gonna set that to our priority. And then here we wanna make sure like after this that we return. And then what is this supposed to return actually? So I got the arguments. I guess maybe return 0 if it succeeds, return 1 if it fails, something like that. I don't know. I'll just assume that's the case. I can ask a question to my TAs about that later, depending on how they want that to be implemented. But so yeah, if we exit this for loop without finding the PID, so we can say didn't find PID, return -1. We'll say that's our kind of our exit case for now. That might change. We'll see. All right. So that should set that pretty straightforward. So just to make sure that we actually have like working code right now, before I get too deep into this, so what I want to do, so let's do, so our class uses this, actually I don't even need to use a Docker container now that I think about it. So we use the CMake thing in order to build all of our files and stuff together. I'm realizing now that I may need to include sketch.h. Well, I don't need to include it yet. So so we'll do a CMake, or sorry, we need to cd to, or well, first we need to create a folder called build, and then we're going to cd into it, and we're going to CMake. We want all of our build files to go in this folder, so that's why I cd'd into it, and then we're going to do a ... to actually get the, you can see here we have this CMake file out here. This is the one that I want to reference. So, and then we want to do it for debug. So that's something like, I think it's this equals debug. CMake error. Oh shoot, that's my bad. I need to put a little dash in front of that because it's a command line option. So yeah, so it writes those files, and then once it writes those build files, then we can just do a regular make to actually make the whole thing. It'll do all that jazz pretty well. Aha, and then it says we have an error. Dot moved backwards before stab. Undefined reference to sys set scheduler. Okay. And where is that? There is in syscall.c. And I defined this. Hold on, we had a little post where they say what to do about this. Let me see if I can figure this out really quickly. Yeah, okay, so in syscall.h, I come down here and I define authorization failures. That's fine, whatever. I'll deal with that later. So, okay, so I added the sys.setScheduler. So this is basically just a number for a new system call. So we add setScheduler, right? So that's here. And then in syscall.c, we should be able to see that then. But apparently it's undefined, which is very curious. Because here syscall.h is included. Very interesting. I'm not sure what's going on there. Oh, wait, okay, this is so this is including sys.syscall.h. This is including bits.syscall.h. Where is this going? I actually don't know. Interesting. I'm pretty sure I was just supposed to add to this one straight up, actually. So that's curious. Curious for sure. Like this should refer to this syscall. But for some reason it doesn't. So maybe I forgot a step somewhere. Syscall extern int sysfork on line 90. Okay, so similar to what we do here, extern int sysfork, then we do the same thing for setScheduler, which I did. Okay, and then similar to what we do for fork here, we want to do the same thing here for setScheduler. But it says it's an undefined reference. I guess is it somewhere I need to actually like define this, I guess? Oh, I see. Hold on. Okay, I know what I did wrong. So I need to go to sysproc here. And yeah, okay, so see how we have sysfork and it calls fork. So similarly, I need to have an int or wait. I guess it doesn't need to, I don't know if it needs to return anything. I guess it would just be void sys set scheduler void. And now what I don't know how to do is how we actually get the like how do we get our arguments? Is that what this is for? It looks like that actually. Actually, yeah, I think this is probably it actually. Argent. What is argent? Let's see. Fetch the nth 32-bit system call argument. Aha. Okay. So we just need to use this 3 times, right? So here they get the 0th one is going to be the PID. The first one is going to be the because here's the in syscall. No, sorry, not syscall. In proc, here's our function definition, right? Our kind of decorator here. We have 3 ints that we take in. So we need to get 3 arguments and then pass them, like that. I don't know if that makes sense to anybody, but it makes sense to me. Okay. So I kind of understand now. So what we're gonna do here, I'm gonna steal some code from here. We're gonna do something like this. Yeah. Okay. So we're gonna have a PID. We're going to have a. I wonder if I could just define them all on the same line. We're gonna have a policy, and we're gonna have a. Does that work? Yeah. Okay. I figured that worked. Okay. Cool. So we're gonna do PID here. And we just need to kind of repeat this 3 times. Here we'll do like else if. Here we do else if. And we're gonna increment this by 1 every time. Here we're gonna do policy. And here we're gonna do priority. So the reason we have to do this is because there's this abstraction between the user space and the kernel space. So the user can call the function set scheduler with the parameters, right? But parameters can't really get passed that easily that way. So that's like we have some sort of abstraction for that here. I don't quite understand how the abstraction works, but I don't think that's super relevant unless something doesn't work. Then it might become relevant. We'll see. Okay. So next up. So once we get our 3 arguments, then we can literally just call our function, right? Then we can just say, okay, set scheduler. And then we're just going to call it. So we're just going to say PID, policy, priority. And we'll just call it. And that'll be that. For some reason it's not finding it, and that is concerning me. Okay, it does take in proc.h. Oh, but you know what? Wait, where did we define this again? In user.h. That's where we put the set scheduler a like initial declaration. Maybe that's not enough? Because this doesn't take in user.h. Huh. I wonder. You know what? We'll just try to compile it again. See what happens. Right? Oh, okay. Something did go wrong. Okay. Return with a value in function returning void. Oh. You know, that does check out. I think this needs to be an int now that I further consider it. Yes. Much so. Okay. Okay, so now we only have 2 problems. Implicit declaration of function. Okay, I figured that was gonna happen. Control reaches end of non-void function. Oh, Okay, yeah, we just need to return whatever comes out of set scheduler. So we do that, and right. So here we need to somehow make sysproc see that the function exists. I feel like exposing user.h may or may not be the best way to do that. I wonder if instead I should just take this and then paste it into proc.c. But it doesn't look like... So I don't know where... Okay, so from this file, if I come up to sysfork, like where is this fork coming from? Like how does it know to go to proc.c, you know? Declaration? Okay, the declaration is in defs.h. So I guess I need to throw something in here. Yeah, let's do that. So int sets. Oh, oops! I already had an int. I see. Cool. That should solve both of those issues, right? Theoretically, it compiles this time. Theoretically. Ah? Okay, cool. It compiled. Very nice. Very nice. Okay. And then so now that we've used make to build our thingamabobber, we can simulate the actual OS with Kimu. So if I run this, then it boots up my OS. Look at that. So we get our OS. We have a single CPU right now. And we only have round robin, right? But at the very least, we have a function that is not, you know, significantly breaking anything. So look, like ls still works. I don't think echo actually exists. Yeah, I was gonna say I don't think echo is actually one of the functions that I have here. I have a very limited set of functions here I can actually use in the shell. But I mean that's not the point of this class anyway. The point is to make it so that it boots up. So, with that, we should probably now actually implement our scheduling policy. So I can exit out of that. I'll kind of close that there. So we're gonna go. Hold on, let me just make sure not missing any. Oh hey, I got a DM from Christine. That's kind of cool. Oh, Uzer, thanks for the follow. I appreciate it. Oh my gosh, today's making me so happy. We got 3 follows today already. Technically 4 if you include Darth. I think he pity followed me after I talked with him in Wush's stream. I think it was Wush's stream yesterday, or maybe it was someone else's stream. Where did I talk with Darth? Anyways. But yeah, we did a thing. That's cool. I like doing things sometimes. Hey, what did Chris tell me? Oh, he just smiled at me. That's funny. Okay. I don't think I'm sorry, I don't think I can share this with you guys, but I just received a very interesting set of DMs. Okay, oh wait, actually, you know what? If I provide enough context. Oh my god. No, I shouldn't. I shouldn't. I shouldn't. I'm sorry. I'm sorry, chat. I shouldn't. I need to be a good person and not leak these DMs. I'm sorry. Maybe someday. um But anyways, back to our process scheduling shenanigans. Um, so yeah, so we added, so in our process struct, right? We have one of these structs for every single process that's running on our platform currently, right? So we have now a field for the scheduling policy, which, you know, honestly, I kind of feel like renaming to just policy. I feel like scheduling policy is kind of a lot, and I feel like policy kind of gets the point across. So now that we've done that, so we have our policy and we have our priority, right? And those are both kind of basically embedded in the definition of the process now. So we're going to use both of those boys, and right, our scheduler, right? Right now this is just round robin. What we need to do is we need to actually look at, okay, is the process marked as FIFO? Is it marked as a first in first out process, or is it marked as a round robin process? And so there's a few considerations that we have to take into account here. I'm gonna make the thing go away. Make the big, thank you. Okay, so we added the system call and all that jazz, right? But for the actual implementation, right? So we've already done round robin, like that exists. We don't need to really do anything with that. But the first in first out, right? So as I said before, with our first in first out scheduler, right? We have a process one comes in like very beginning of execution, very beginning of like our boot up sequence essentially of our OS, right? Process one is going to keep running for as long as it likes, right? Until either it finishes, like it finishes executions, like, okay, I'm done, process one is done, or it exits on its own, right? So in that case, what we're gonna do then, if it exits on its own or if it finishes, is we're going to look for the next process, essentially, that came in, right? First in, first out. Think of it like here, another shitty paint drawing. So you have a bunch of people in line, right? Let's just put a bunch of people in line. All right, they're just all standing here. This is a top-down view, and we're waiting at the fucking, I don't know, the lemonade stand, right? Lemon. All right. So we're all waiting at the lemonade stand, and like, okay, so this guy came in first, right? So we're on this dude, right here, right? So he comes up. Taro, thank you so much for the follow. I appreciate it. I hope you're enjoying my lemonade stand explanation of how a FIFO queue works. I didn't think I was gonna be here ever, but essentially, so essentially, oh, it would be helpful if you guys saw what I was drawing, huh? So we have our lemonade stand, right right here. This is our nice lemonade stand. We got our people in line, right? So this guy that I have the arrow at right here, this guy's the first one in line. He goes up to the lemonade stand. He's like, all right, Mr. Lemonade dude person guy, I would like lemonade. He gets his lemonade, and he finishes getting his lemonade, right? And then he's like, all right, I got my lemonade. Get me the fuck out of here. All right? Q moves up. Okay, now we're on person number 2, right? So now we're here, and person number 2 is like, I don't know, do I want lemonade or not? Like, person number 2 is not ready to order this lemonade, right? So we're like, you know what, person number 2, you need to get the fuck out of here. So we move person number 2 all the way to the back of the line, right? And then we say, you know, just go to the next person. And so now we're on person number 3. Person number 3, he can take as long as he like to order this lemonade. Maybe here, honestly, bad explanation. Person number 2 is like, oh, I'm still deciding on which kind of lemonade I want. So he just chills there, right? He's just vibing. He's just vibing, looking at the menu for like 5-10 minutes. All these other people are in line. Maybe there's like more people that start getting into line. Like, you know, we got big guy, we got small guy. I don't know. It stops being a line even. Like, you know, I feel like this is what lines look like sometimes. So just some social commentary to just sprinkle it in here. But essentially, person number 2 here can take as long as he likes. And unless person number 2 looks behind him and says, oh shit, there's a lot of people behind me, I should probably let someone else go first. Person number 2 can just stay here and keep looking at the menu as long as he wants. And then finally, after person number 2 finishes ordering, or after person number 2 is like, oh shit, I should probably get out of here, then person number 2, you know, gets the fuck out of the way, and then we get all these other people come up, and now they get to order. I guess this person gets to order. They were third in line. That's how FIFO works, right? It's literally just like people standing in line. That's all it is. And that's the end of my TED Talk. Goodbye. No, I'm just kidding. So yeah, so that's first in, first out, right? Now, so the thing with FIFO is that now that we also have this concept of priority, right? That was introduced. So let's say in our lemonade stand example, we have a fucking let's say we have like Britney Spears or something comes up to this. That might be a very, very dated celebrity example, but let's say Britney Spears let's say Pokimane walks up to the lemonade stand, right? Like you know, I'm no Pokimane simp, but like I'm getting the fuck out of line so that Pokimane can pass me and get her lemonade first. Like I feel like that is just a nice thing to do for someone that has provided so much content to the community. Where does this assignment come from? This is so are you pick up the lab or on the web, or are you studying it? I'm studying this. I'm currently in an operating systems class. Just thought I'd share my thought processes with the world on a nice Friday morning. But yeah, so if we say Pokimane, you know, comes up, Pokimane's like a VIP essentially, right? Or let's say Christopher Yee comes up. I'm like, oh my gosh, Mr. Christopher Yee, love your content, man. So Christopher Yee comes up, and I'm like, okay, shit, let me get the fuck out of the way. Let me give up my spot in line, right? So I would say that these two people have what's called priority, right? They have a higher priority than me. Or maybe the people at the lemonade stand are like, oh, is that like ABBA? And then they're like, oh shit, it's ABBA. Okay, ABBA, come to the front of the line. Like, the lemonade stand wants to serve ABBA first. They don't want to make ABBA stand in a line of 50 people or something, right? So that's that concept of priority. So even though we have this first in, first out idea, even if I'm first in line, if somebody with higher priority comes up, right, like, then I am going to give up my spot so that the person with the higher priority can come in and order their lemonade. Same idea. Um, hopefully that example wasn't too contrived. But yeah. Yeah, but yeah, this so I study at Georgia Tech. I am in my final year of my bachelor's as a computer science major. And so this is an OS class that I'm taking as part of my system architecture thread. So if any of that meant anything to you, then congratulations, I guess. um, but but yeah. Uh, You're starting IT security. Oh, that's awesome. Very cool. I have some friends that are taking an infosec class right now, which seems pretty interesting actually. But I'm not. I don't know. I'm not super knowledgeable on that stuff. I have like a vague understanding of like public key cryptography and stuff like that. Um, and also like end-to-end encryption is something that I'm somewhat familiar with. But honestly, other than that, like I'm not very familiar with that stuff. You want a class on OS architecture? Oh, neat. That's cool. Um, yeah, I guess maybe it was kind of similar to what this is, honestly. Um, could be, maybe not. Who knows? Um, but yeah, okay. So we need to implement this priority thing. Okay, maybe before we implement priority, maybe we like write some code for FIFO. Maybe, I don't know. So so here's the thing, right? Um, so let me show you how like currently how we implement this round robin concept. So there's this file called trap.c. Um, Without getting into too much detail, essentially a trap is some sort of predefined system function that we can use. Um, but what happens here is if I just skip to the end of the trap function, check out this guy. This little section right here. So force process to give up CPU on clock tick, right? What this is saying is that like on this timer or whatever, um, like this interrupt was called that says, okay, we've hit the timer. This process needs to yield. That's how round robin works, right? In our, going back to our, oh, this is this is not the right. Well, I can make it work. So let's say, so this is our process table again. So we have ready process, not ready process, ready process. Right. So we come in from the beginning, and we start here, right? But then, regardless of whether or not this process finishes, after like let's say 100 milliseconds, then we say, okay, you took too long. We're gonna go to the next process. That's how round robin works. We're gonna wait another 100, and then we're gonna come here. But this one can't run, so we're just gonna keep going. And then here we'll wait 100. Maybe one of these processes exits before 100 milliseconds. But if it doesn't, like, yeah, we kind of just like keep coming back. We'll keep going, yada yada yada, keep going, and that one's still not ready, and keep going. Eventually one of these processes will exit or something like that. We can then cut that process out of the, I guess, the round robin cycle, and all is well. So round robin, we have this timer concept, right? In FIFO, we don't have a timer concept. This process keeps going until it finishes. So we don't want to force the process to give up control if it's a FIFO process. So how do we want to check that? So first, I want to include sketch.h. So in sketch.h, this is a file that I created. I've defined two scheduler policies. This is my sketch RR, my round robin, and my sketch FIFO first in, first out, right? So if in the case where the so here I also want to check for the condition where my proc dot policy, right? I only want to force the process to give up on clock tick in the case where the policy is set to sketch RR, right? Does that kind of make sense? Like, we only want to actually use these clock ticks. We only want to activate our scheduler on these clock ticks when the process we're on is a round robin process. Okay. So that's one thing, right? The other thing is let's look at how this works. It does make sense? Okay, cool. Thank you, Taro. I appreciate it. Yeah, so okay, so now that we specified basics of FIFO and RR scheduling, yada yada yada, specify our priority policy. Okay, so each process has both a scheduler policy and priority. When each of your schedulers are selecting a process, the scheduler should obey the following rules. So if we have any FIFO processes, first of all, if we have any FIFO processes in our process table, we should always run those first before the round robin processes, right? Also, we need to make sure that we always run the highest priority process. So the kind of the delineation, right, is so we have I'm gonna delete this. Probably won't need it. So we kind of have this like flow chart, right? Whenever we're scheduling a process, right? So we say like something like, okay, is there a FIFO process? Let's yeah, is there a FIFO process in the is there a FIFO process ready? Let's say. So if there's a FIFO process ready, I don't know what the hell this font is, by the way, so we're just gonna run with it. But yeah, so if there's a FIFO process ready, let's say like yes, right? Then we're going to run highest priority FIFO process available, right? Okay, otherwise we're going to run highest priority round robin process available. Oh wait, sorry, I put the yes on the... No, I did put the yes on the right side. Okay, so if there is a FIFO process ready, then we run the highest priority FIFO process available. Otherwise, so in the case where there isn't a FIFO process ready, then we'll run the highest priority round robin process available. So that's kind of how the scheduler flow is going to work, right? So let's start with the is there a FIFO process ready part. So essentially in our scheduler here, which file is that? There will be a famine problem if there is always a FIFO process coming in. That's true. Yeah, you'll have a situation where you're only running the FIFO processes and you're never running the round robin processes. But at that point, it's kind of it's more an issue of like user misconfiguration. Like if you think about it, it's kind of like if like enough processes mark themselves as FIFO, then your quote unquote throughput, right? Like the like how much work you're able to get done is going to be limited to like this one process for a very long time, and then if it'll finally finish or something, and then you'll switch off to the next FIFO process. But in reality, what might happen is like you would want to configure your system so that unless it's something that you really need to get done like immediately, like something that's like I don't know, like oh, like you know, the user just opened a program. Like let's say I come down here and I open Steam, let's say, then uh my system can put aside the like in the immediate sense can put aside the um like oh, like we need to load the definitions of all these functions, because like that's not really like a, I mean, that doesn't have to happen like immediately, you know? Like you can even load it like when I hover over it. It doesn't have to be loaded beforehand. It's just like if you have enough time and there's nothing else running, then you can load it before. So that would be like a low priority thing, and also something that you wouldn't really give first in first out, first in first out policy. But like yeah, if I'm like, oh, I want to launch Steam, like I want Steam to open as quickly as possible. Um, as the user. So I wouldn't want Steam to configure itself as a at least the launcher, the initial launch, to be like a first in first out kind of thing. And then maybe the policy after that change, like maybe once I have my library open, right? I have the library open now, and now I'm like looking at my list of games. Like now it doesn't really need to be first in first out. It can kind of be like it already loaded everything, you know? So it's like it's kind of just there. And maybe I'm just gonna close it anyway. So like, what's the point of loading all that stuff beforehand? So there's a lot of kind of like things to like think about, and there's also this concept of, it's like, you know, it's not like a black and white thing either, right? Like you're not gonna have only these two policies, these scheduling policies either. So there's a whole slew of other scheduling policies that we haven't even touched on. So, yeah. Don't know. I mean, like, so you're correct that there would be a famine problem. But you know, in the real world, I think the user would probably, you know, better configure the system, so maybe more cores, or you know, faster components or something like that. I mean, it's like how we upgrade our computers, right? We got a new laptop with a better processor, or faster memory, or we will upgrade our desktop with like a faster GPU or a faster CPU or something like that. So like that's one way to overcome that hurdle. Like how many times is your CPU actually at like 100% on your computer? I don't think mine is ever at 100%. Like I'm streaming right now and everything. And like my CPU is at 13%, my GPU is at 31. You know, so I don't know. So just depends. Yeah. Okay, so we have this way to like only break if it's a round robin process. But here's the problem, right? What we're gonna find here is when a new process becomes runnable, if it should run before the current process, your scheduler should immediately preempt the currently running process and schedule it. So how do we do this? How do we preempt the currently running process? This is something that I'm not sure about. My GPU is at 40% just watching the stream. I mean, like it's like it's like somewhat similar. Um, yeah, because you have to like decode all of that data. Like if you're like I'm streaming in 1080p right now. I assume you're watching a 1080p. Like that's like millions of pixels. Like how many hold on. I'm actually a little bit curious. Let me open a tab real quick. So or maybe a calculator would be better. So 1920, right? That's the width times 1080. So my stream right now is oh, you're in 480p? Okay, gotcha. I guess I'll do this math anyway though. But like 2 million, over 2 million pixels, and like I'm streaming at 30 FPS. So 2 million pixels 30 times every second, roughly. It's a lot of pixels. Um, so most of the screen isn't refreshed every second. That's true. Um, but like your GPU has to do some work in order to like I don't know, how am I trying to say this? Like there's some like decoding work, and then there's also some like displaying work, I guess. Um, I'm not okay. This is getting into territory that I'm not super familiar with as far as like how the like graphical like stuff operates. But I'm pretty sure that it's kind of this like system where you decode the data from the internet. And like that's one step that the GPU does, and then the GPU will also like actually display that on your monitor. Um, I believe there's kind of two parts to that. That's why there's this like this concept of hardware acceleration that like Discord and Spotify and so many other applications use. Something like that. Uh, but yeah, this is the hard part, right? The when a new process becomes runnable, if it should run before the current process, your scheduler should immediately preempt the currently running process and schedule it. And here the exception is basically that if there's multiple CPUs and an action on CPU running process P1 causes the process to become runnable that's not higher priority than P1, but is higher priority than process P2 currently running on a different CPU, then C2 need not preempt P2 until the first an interrupt to C2, P2's completion, or an event which causes P2 to suspend. So essentially what that's saying is that if I have if a process that was on CPU 1 or sorry, if CPU 1 somehow causes um causes a process that's higher priority than something running on CPU 2 to become runnable, then we don't need to preempt CPU 2, because I think that would probably be a pain in the ass anyway. So essentially what we need to do now is in our scheduler we need to figure out some way to like actually like preempt this process. How do we do that? I'm not sure actually. How do we preempt? Let me just search the code for pre. Okay, well that didn't work. Okay, that doesn't help. I don't think that's. Okay, here's some sort of preemption. This is like a test or something. So I think this is just creating three processes, and it's seeing if they. I'm not sure actually. I'm not sure what's happening here. Like this is just a like oh, I see. So the for loop is basically like, so if fork is not able, if it's not able to create a process, then we're just gonna loop forever. It's kind of like a panic, I guess, but it's a pretty shitty panic. Same thing with number 2. Same thing with number 3. Yeah. Cool. Cool. Okay. That's not terribly useful information. Well, we're kind of in the dark here, I guess. I was hoping there was gonna be something else in the code where there's like some sort of preemption. I guess because the problem is like yield, right? Actually, no. Maybe we do just use yield. Maybe it's yield. Is this what we're supposed to use? Okay, what is in sketch? What is the difference between sketch and scheduler? I'm confused. Oh, I see. So this will switch the context back to the scheduler. Okay. Got it. I understand. So okay. So here's the thing, right? So we have this we have this thing where we switch, so we switch our CPU to the other, we switch our CPU to the actual process, right? So this is that context switch I was talking about, where we literally just we switch from scheduler to the process, and then what? Like, we just have to wait for it to give us back control. So I'm like, I'm not sure how we actually say like, okay, come back. Like how do we like make it come back? I wonder if there's some sort of like, maybe there's like an interrupt or something that we can use. Let's see what some of the people in my class said. So priority policy. Okay, I'm just looking at what some people said. So FIFO. Okay, first of all, FIFO should always preempt RR. FIFO process, higher priority process should preempt a lower one, and yada yada. For priority system for RR, highest priority always gets scheduled. Interesting. Okay. Huh. Okay. So here, detecting when we should preempt the current process. Get some guidance at a high level at how we might detect when we need to preempt the current process and how we might actually execute a preemption. Great question to be thinking about. In general, you hit the nail on the head. You should consider preemption when the process priority or state changes. In these situations, our choices for which process to schedule next will likely have changed. So we actually, so we actually want to. So here's the thing, right? So our scheduler will look at every single process and choose the best one to schedule on the processor. But what if the state of one of the processes changes, and the only way that the state of a process changes is through the function that we literally just wrote, set scheduler, right? So here, what we can do in this function is so after we set our policy, then we need to check, do we need to preempt the CPU or the currently running process? So we need to check this, right? And we're gonna have some sort of condition that checks that, and if it's true, then we're gonna yield. We already have this function yield, which gives up the CPU, and it'll go back to the scheduler. So here now in this if statement, then we can have some sort of condition which checks, like, you know, a variety of conditions. So what are the cases? What are the cases where we would want to preempt? So there's I guess there's 4 possibilities, right? So there's round robin. So both the process that we're changing the, like, I guess the data for is round robin, and yeah. So both that process and the one that's currently running are both round robin. Maybe one is FIFO, the other is round robin. And then there's also the vice versa of that. Like, the one is FIFO, the other one is, or one is round robin, the other one is FIFO. So like it's kind of like flip flopped. And then the last one is the situation where they're both FIFO. So in the situations where either where like basically their policies equal one another, then if yeah. So here's the first condition. So I'm gonna do multiple kind of parentheses here. So first of all, if priority, or sorry, if policy equals my proc, right, dot policy. So if they're both FIFO, or if they're both round robin, and right, and the priority is greater than the priority of the currently running process, then we need to preempt. Okay, right? So that's one situation. Okay, so then we have an or. So what's next? So another situation that we could have is I'm just gonna kind of like line this up the same way. I don't know. I want it to look nice. Okay, so or and maybe I can zoom this in a little bit more, or maybe that's cursed. I don't know. Or the policy of the okay, so the other situation, right, is that so if the one that we're changing right now is round robin, and it didn't go into this situation, then that means that or sorry, wait. So we don't really care if this process that we're changing the information for is round robin and the one that's running on the CPU is FIFO, right? Because we don't need to preempt for that. The FIFO one should keep running. But if the one that we're changing the information for right now is FIFO, and the one that's running right now is round robin, then we do need to preempt. So here we're gonna say if policy equals sched. Oh wait, hold on. I need to include that, don't I? Include sketch.h. So we include that, and so then we say, okay, sketch. If the policy is FIFO of the one that we just changed the data for, and my proc policy is the opposite, essentially, is round robin, right? I don't get it. Why would you check if they have the same policy? Okay, here's the thing. So I'm gonna go back to paint. So we have 4 situations, right? Let's see how I can do this. So we have 4 situations. So this is situation 1. We'll say situation 2, situation 3, and then situation 4. I'll reorganize this. This is going to be process 1 and process 2. And then here, these are both going to be round robin in this case. Right? Oops. Yeah, it's whatever. Actually, it's not whatever. I should make that a little bit different. So let's say in this case, they're both round robin. Yeah. Or here, rather, I'll bring this down. Okay. And then we're going to have one of these for like every single situation. Okay. And in this case, it's taking slightly longer than I thought it would. Okay. We'll take our FIFO and just copy paste that. Shit. Okay, so these are our four situations. And yeah. Okay, so in the situation where both are round robin, I only want to preempt. So only if the priority of the first one, so it's like PR1 is greater than PR2, right? In situation 2, and let's say priority, or let's say process 1 is the one that like we changed the data for just now. So in this case, we only preempt if PR1 is greater than PR2, and I can probably draw my P a little bit better. Okay, in situation 2, this is round robin. FIFO always goes before round robin, so we don't need to like do anything at all, like in any situation. In the situation where the one that we're changing is FIFO and the one that's running is round robin, we always preempt. And in the situation where they're both FIFO, then again, we only preempt if priority 1, the one that we just changed, is greater than the one that is still running. Why don't you just check that my proc is not FIFO? If my proc is not FIFO, so we can't just check if my proc is not FIFO, right? Because just because process 1 isn't FIFO doesn't necessarily mean, like, look at situation 1 here. Just because process 1, the one that we're changing, isn't FIFO doesn't mean necessarily that we aren't going to preempt or that we are going to preempt. It's a conditional here. So we have to check that condition. Chichen Itza, hey, welcome. Welcome to the stream. Yo, does the scheduler schedule processes or threads? So this scheduler that we're working on right now is scheduling processes. This is a process scheduler. And so the two scheduling policies that we're working with right now are round robin and first in, first out. So round robin is our FIFO is first in, first out. I thought you'll never preempt a FIFO process. Yes. So if it was just FIFO, you are absolutely correct. But here's the thing. Here's the thing, right? Now we have priorities coming into play. We have this concept of that, like, every single process has a priority. And so if we have process number 1, FIFO, come along, and this process now has a greater priority than the one that's currently running, then we do need to preempt. You got it? Okay, cool. So it's like a very, very, like, interesting kind of situation. Like, you're correct that you wouldn't normally preempt a FIFO process because it kind of goes against the whole idea of FIFO. But that's why we have this idea of priority, because back to the Chichen Itza, you weren't here for the lemonade stand example, but essentially you have a bunch of people standing in a queue at a lemonade stand, and if Pokimane comes around, Pokimane, very high priority person, she can just walk up to the front of the line, get her lemonade. I'm sure no one will mind. So yeah, that's kind of how it be. Nice, yeah. Yeah, exactly. I had a beautiful diagram for the lemonade stand example, but I threw it all away. It's a damn shame. But yeah, so we do actually need to yield. So yeah, so here, so let's bring up this paint window just next to our condition here. Here, this is what I'm gonna do. I'm gonna take these two and we'll bring them down here. Aha, big brain. And then we can bring this off to the side, right? And we can look at our whole condition and our whole paint drawing. Well, I can see my whole paint drawing. You guys can't see part of it. But so this condition right here, so this one and this one, and maybe it's easier if I do different colors. Let's do green. So this one and this one are both, like, described by this if statement. So if the policies are equal to each other and the priority of the one that we just changed is greater than the one of the one that's currently running, then we preempt. In a situation where the policy we just changed is a round robin policy, we don't do anything. Where it's currently round robin and the other one is FIFO. But then in the situation where the one that we just changed is FIFO and the one that's currently running is round robin, then yeah, we need to preempt in just all situations. We need to yield in any situation. Yeah. So that's how we preempt, I guess. Yeah. So okay. So we do the whole yield thing. We go. So now we yield, right? And now we come back to the scheduler. I might have scrolled past it, I'm gonna be honest. Oh, here it is. Okay. So we come back to our scheduler, and we need to now change like what we're actually doing here. Right? It's fine to acquire this p table lock. But what we're doing here was like extremely basic round robin. And we need to now not only accommodate for also having first in first out, but we also need to accommodate for this idea of priority. And in order to accommodate for this idea of priority, we honestly need to just loop the whole process table every time we reschedule. Because we need to look for like the best process to run, right? So essentially the way we can do that is let me show you actually. So we're gonna have struct proc p, and then we'll also have another one that's like we'll call it best, right? So we'll keep track. So we'll loop through the whole process table, and we'll keep track of the best process that we find to schedule. Yeah. So in that case, yeah. So in that case, what I'm going to do, I actually will want to probably change up my for loop a little bit. But yeah, I'm actually getting close to the time that I agreed to play Mario Kart with some folks. So I'm gonna probably close this stuff up for now. And we will come back to this. I don't know. Maybe I'll work on this some more tomorrow. I'm not sure. Not sure yet. Chechen Itza, thank you so much for the follow. Oh my gosh, dude, this is so exciting. I didn't think I was gonna get this many follows. This stream. I'm glad people are interested in this stuff because I like streaming this stuff. I hope I make it interesting. Okay, nice. Yeah. Yeah, Taro, I'm glad that you stuck around for so long. I'll definitely watch the end of your lab if you stream it. Yeah. Okay, yeah, honestly, in that case, maybe I will then. Yeah. But yeah, I'm gonna switch over to some Mario Kart now. Well, you know, not like immediately, but in a few minutes. Yeah, let's change the stream title so people aren't confused. Oh wait, why isn't that typing? Mario Kart. Readying up for some Mario Kart 8. We'll change this to just chatting. We're just chatter now. Sure. I don't know. Yeah, I don't know. I don't know what to change it to. I mean, that's probably good. Scheduling is a popular topic now because of Go, I think. Oh, really? Like Golang? Is scheduling a big thing in Golang? I'd be surprised if it was. Golang scheduler. Job scheduling package. Interesting. They ask a lot about scheduler on Go interviews. Oh, huh. Interesting. I'll maybe watch rebroadcast. I'll be on my PC when you do it. I gotta go. TY for the stream. Have a nice day. Thank you, Taro. Thanks for sticking around. Hope you got something from it, and yeah, hope you can catch the next one. I'll maybe do it tomorrow. We'll see. We'll see how I'm feeling tomorrow morning. But in any case, yeah, thanks for sticking around. And I'll see you next time. Yes, sir. But yeah, oh, okay. So I didn't know they asked about schedule and go interviews. Chichen Itza, if you don't mind me asking, like which companies are you interviewing for? Or which positions are you interviewing for that are asking for experience in Go? Because I've coded in Golang before, um, for doing some like server stuff, um, but I actually haven't heard of that many people like using it in their job. So I find that curious. I'm a Russian Go chat and oh, I'm in a Russian Go chat and people share their interview questions. Ah, I see. Huh. That's really interesting. I'm surprised. That I don't know. Whenever I think of like a scheduler, I never think of like I don't know. I consider Go to be a higher level language. You know, like Go doesn't seem like a I don't know. Maybe I'm wrong, but Go seems like a very much like high level language to me. Like very much like kind of okay. Application level is the wrong term to use, but I don't know. Hmm. Yeah, it doesn't strike me as a language that would even require the knowledge of how a scheduler works. Um, but I mean, it's not that hard to learn how schedulers work either. So maybe it doesn't matter. Maybe it's not a big deal. Like my whiting is. I have a lot of whiting coming from the window now. I usually stream at night. Fridays are the only days that I stream in the mornings, or in the afternoons. So I never have this problem with like light coming from the windows. um, but yeah. Wait. Oh no, dude, my Mario Kart lobby was actually it's actually 12 p.m. PST, not 12 p.m. EST. Oh, that sucks. I should have like confirmed that. I should have confirmed. Oh no, I didn't read. I'm so bad. I'm so bad at reading. So it's 3 hours from now. Dude, I can't even tend that. Damn. Oh no. I fucked up. Oh. Oh my god, I fucked it so bad. All right, well, I uh That is unfortunate. That's I I just completely misread what the. Oh my gosh, that is so unfortunate. I completely misread what the announcement said. You know what? I'll give you guys some I'll give you guys some Mario Kart anyway. But it's gonna be by myself, and I'm gonna not be as happy as I would have been if I was playing in a lobby. But all right, let me get that pulled up real quick. I need to plug in the like cable or whatever. All right, I'm back. Here is the Mario Kart, and by the Mario Kart I mean the home screen to my Switch, which is very much not the Mario Kart. All right. Hopefully the volume on this works. If not, I'll be a little bit sad, but not that sad. What am I looking for? Oh, I'm on the wrong scene. Okay, hold on. I was like, okay. I need to pause the music. Oh, I'm not getting any volume. Hold up. I'm not getting any volume. Why is that? We'll try just unsetting it and then resetting it, maybe? Would that work? Okay, that didn't work. Hmm. Maybe if I unplug it and plug it back in. Okay, but that might do all sorts of weird, fucked up shit. Hmm. Why is there no volume? Uh, hmm. Hmm. This capture card is quite the anomaly. I'm gonna be honest. Let's go to my control panel. See what's up. Manage audio devices, recording. Okay, yeah. Well, it says there's nothing coming out of it. So hmm, very interesting. Yeah, maybe I just need to hold on. Let's try something. We're gonna unplug the switch and then we're gonna plug it back in. Okay, that didn't do much. We'll unplug the capture card. Okay. We unplug the capture card and we plug it back in. All right. I don't think that did anything. Is this just gonna be the most scuffed stream ever? Please no, not like this. Please. It keeps like connecting and disconnecting. I'm just watching it like this is so weird. Oh! Wait, we got something for a little bit. We got something for a little bit there. Where'd it go? Where'd it go? It was just here. Please. Come back. Oh my gosh. What did I do? I swear I didn't do it. Is it like not plugged in all the way or something? Uh yeah, it's like I don't know, it's doing something really weird. Hold on. I'll try another port. Okay. It's not unplugging itself anymore. And then if I plug in, bam. Okay, it's working. And so now if I change this to that, wait, I may have done something incorrect. Oh shoot. Nice. Oh, thank God. Okay, we got it. And now this is way too loud now, and I need to turn it down. All right. Well, that was weird, but it works now. Holy shit! Only took a fucking year and a half. Oh my god. Dude, I bought another capture card that's like slightly more expensive, and I'm just... Oh wait, why did I choose friends? No. I'm gonna play some, should I play regional or worldwide? I don't know. I feel like worldwide, there's probably too many sweats. I'm gonna play a regional. Or a regional person myself. I kind of want a little bit more handling if possible, but maybe I'll just take the traction, honestly. Sure. Give me that. Let's see. Rainbow Road? We'll do Rainbow Road. Sure. Sure. Why not? On the bright side, I get to change my follower goal. That follower goal has been up for a long time. Finally crossed 200. That's so fun. That's so cool. I'm happy. I'm happy that happened. Makes me feel like I'm achieving something. All right. You live in the US? Yeah, I do. Yeah. Oh shoot. I forgot to boost. No, here's the thing, right? I feel like there's gonna be a lot of sweats on like Japan servers, so I would rather play on the US servers. There will also be sweats on the US servers, but I don't think they'll be as bad. Oh, I almost got hit by that. Holy moly. Oh shit! Oops. Did that guy just get stuck? Did Waluigi just get... You live in US? That's crazy? I feel like, okay, I feel like it's not that crazy. Oh, wait, what did I get hit by? Oh my god. Oh no. Oh, I'm not doing that well. I'm not doing that well at all. How do I only have a single mushroom in 10th place? I need to pick up an item real quick. Oh shit! I specifically drifted to avoid that banana and somehow I hit it anyway. Wow. Well. Ooh. Oh my god. No, my boat fit. Oh my god. Dude, how was I not able to make it over that gap? Holy shit. I'm so bad. Oh. Oh. Oh, dude, but I got 69. Nice. I got 69. Honestly, maybe that's all that matters. Well, I like Rainbow Road. I also like Toad Harbor. I'm not a huge fan of Bone Dry Dunes. Chechen Itza, what are you thinking? Toad Harbor or Rainbow Road? What's the play? What's your idea here? Which one would you rather take out on a nice stroll, a nice date? I'll just choose Rainbow Road. It's what you would have wanted. Just play random. Oh shoot, the message came in too late. I'm sorry. Next time. Damn, bro. Yeah. I'm sorry, man. It'd be like that. I wish there wasn't the... Wait, is this the Squid Game guy? Is this guy just Squid Game? He has like the circle on his face. That's kind of funny, actually. Alright, well, we got Bone Dry... Whatever. The only one I didn't want to do. Oh. When did I move to the US? I've always been in the US. Yeah, I was born and raised. Woo! Why does everybody have a bread shell? And why is everyone Waluigi? Wait, everyone is driving like almost the same car. Is this like some meta or something that I'm not aware of? I don't know, man. I just wanted to play my Rosalina scooter thing. Ah, shit. Cool. Okay, 3rd to 7th. Not bad. Oh. Ow. Pain. Oh, I should have saved that. I should have saved that for the jump. Oh well. Dude, he's just carrying the star all the way to the front. Do you see that? That's so funny. That's crazy. Ooh. Woo. That is wilding. And I'm at 11. What happened? I was doing so well. Bullet bow and a mushroom? Okay, this might be big, maybe. I don't know. Apparently I'm also... Oh, what? Why? Dude, it literally it kicks you out of bullet bill with like no indication that it's going to kick you out. Oh, dude, how did you get a bullet bill, mushroom, and 2 stars, and I haven't been able to catch up? How far ahead is everybody else? Fuck. I hit so many walls. Shit. Oh, no wonder I'm in the lobby of fucking all these people with 20,000 points. I was like, wait, why am I doing so bad? No wonder. It just decided to put me in this lobby with all these really high score people. You know what? I'm here for the challenge. Give me fucking water park, man. I am not a fan of how this man's name is Wet Fart. That just doesn't sit right with me. Oh my gosh, bro! What an interesting lobby. Like how did the game decide to put me, like a thousand point Andy, into this lobby? But look at all these other people. Dude, this guy has 76,000. This guy has 99,000 almost. Jesus. Or maybe that's all. Maybe that's the only people that are even playing right around this time. Wait, someone smoked out? Hell yeah. We take those. I'm scared of that banana that guy's holding. Okay. Oh, no way! The fucking thing jumped right when I... Oh, that sucks. Dude, if I get anything other than, like, last place, I'm gonna be happy. Oh, shit! I didn't see that. That was not good. Oh shit! Oh fuck! That could have been bad. I'm not gonna get hit by the fucking music note again. Okay. I'm in 11. But there's still one more lap. There's still one more lap. There's a possibility here that I make it out of this. And not 11. Don't hit me. Don't hit you, bitch! Man, he really did not want to get 11th place. Oh, fuck! Fuck me. Fuck me. Fuck me. No, there's no shot I catch up. Holy shit! Wait! No pass. Dude, he lost 33 points because I bullet billed past him at the end. Wait, what is this cart combo that these guys are using? It's definitely, it's the Wiggler for sure. It's Wiggler and on Waluigi. Wiggler on Waluigi. And I think that I saw someone with the Azure Rollers. I don't know what height. Why do they choose this? I want to know. Hey, Jiggles, how's it going? I accidentally made my way into a lobby of a bunch of people with a lot of points. You'll see it pop up here once it chooses the course, but I don't know how I got here. Look at all these people. I have 1,000 points. Look at me. That's me right there on the right. And then all these other people have like 20,000 points. How did I get here? But yeah, I just took the cart that everyone else is using. Maybe that'll work out. Oh, I still need to buy Mario Kart? If you do, let me know. Let's play it. Oh, I didn't get an item. That's not good. Ow! Okay, off to a great start. Off to a very great start. Oh! Oh, this is kind of a fun, whatchamacallit here, actually. Alright. Let's see what we can make happen. Oh shit! Damn it. Can't make mistakes like that! Can't be making those mistakes! Dude, someone's name is Wet Fart. I think it's the funniest thing. Okay, this cart combination is actually kind of fresh. Blue shell? Sure, why not? Oh fuck! This thing drifted way more than I was expecting. And just like that, I'm now in 12. Can I catch up? I don't know. Honestly? Alright, we'll see, we'll see. Bullet bills have gotten me farther before. Alright, we'll go this way. Okay, we'll avoid that shell. Take the jump here. Okay, as soon as we win. Oh no! Fucking win! The fucking blue shell hit me out of the air mid-air. That's so sad. Oh, wait. 9! Let's fucking go! Chechen Itza, you can use BTTV emotes for free. I don't think I have any of my own emotes on there, but I should probably put them on there. Pain. Oop. Dude, how many points did I get? I actually didn't look. Dude, I got 9. That's all I could ask for. Honestly, I've been getting 11th and 12th. All of these races so far. 9th is an improvement. What the hell is going on? His actual pain. Wait, it's 200 cc? Oh shit. Oh dude, the fucking one person from Australia is just like, I'm a cunt. Oh my god. That's kind of funny. Let's see. Oh, I jumped way too high. And this is also very fast. Holy shit, this is so fast. Oh, shit. I hit the wall. Damn it. Fuck. Oh my god, he almost hit me. Monkey. How do I use... No, so I don't see the BTTV emote. So the thing with BTTV emotes is that it has to be added on my channel, I think. Oh my god, dude, I'm hitting the walls like crazy. I should have just saved my fucking mushrooms. There was no point in using them. Holy shit. Who made the decision to add fucking whatchamacallit? Mushrooms to 200cc, man? What? The bullet bill always decides to put me out in the worst fucking spot. I swear. Okay, that's fine, that's fine. We got 9, Woo! Monka steer? Wait, do I have that? Monka... No, I only see Monka S, Monka W, Monka I probably just don't have it added on my side. Yeah. Damn. I don't have that many emote slots is the thing. So Ice Post. I'm a fan. Dude, what if I hit him with the I'm using tilt controls? Wait, it didn't make me say it. Why not? I wanted to say I'm using tilt control. Okay, I'll do it next time. Oh, we have a full lobby. Interesting. Oh. Did anybody text me? Oh, thank God. Okay. Nothing going on yet. Three. Alright. Nice. Okay, we got a boost. It wasn't a good one, but it was something. No shit! My item! Oh, that's so sad. That's so sad. Oh fuck. Oh fuck. Oh, I didn't hit anyone? Damn. That sucks. Okay, well, I tried. I tried, guys. Oh, it's been so long since I've even gotten the figure 8. I cannot control my car. I go way too fast with that figure 8 shit, dude. No, I didn't make it. I didn't make it. I shouldn't even tried. Oh, oh my God! I almost got hit by that. Oh no. Okay, well I'm firmly in 12th place. Let's see if I can drift into this double. Okay, cool. There's potential. Okay, it's a mushroom. Okay, I'm hitting all the walls. Alright, okay, well, I got 12th this time. Yeah, that's rough. Oh, I only lost 3 points though. We're still in the positive for today. I started at 1,069, we're at 1,080 something. Not bad, not bad. That's crazy. Dude, what if I actually come in here and just say I'm using tilt controls? Will anyone else say it? I want everyone else to say it. Is that so much to ask? I'm out of here. Everyone picked F-Zero. So interesting. Well, I guess half the people picked F-Zero, half the people picked random, and then there's just me with Cloud Top, whatever. All right, Mute City. Do I know how this map looks? Oh yeah, I know how this map looks. Okay, this map's funky. I mean, we got this though, right? We got this. I might have started too early. Oh no, I started on time. Let's go. No, my item! Shit. Holy shit, I keep missing all the items. Damn it. I figured I was gonna get hit by that eventually, but I didn't think it was gonna be so soon. Cool. Alright, we'll just cruise over this. I think I hit both of them. Oh, it didn't matter though. I missed! Shit! Holy shit. Wait, he missed? He missed the item boxes. Oh, I could have got deeper on that one. Nice. Cool. We got some flowers off there. Oh shit. Oh shit. Not good. Nice. Okay. Oh, I didn't make it. I didn't make it past him, but I got 10th though. I'm better than nothing. Better than nothing. We take this. That's probably like 10 points. Okay, 4 points. Sure. Sure. Whatever. Oh my gosh. Okay, if we can get to once I get to 1100, I will end stream. Can we make it to 1100 points, boys? Let's say 1100 in the next 30 minutes. I'm gonna make a start a prediction here, actually. Can we make it to 1100 points in the next, by 1 p.m. EST? There we go. Yeah, of course. Nah, I don't think so. Do I got 2 minute submission period? There we go, there we go. Oh man, I missed the start, but that's okay. We'll catch up, we'll catch up. I'm gonna say we'll catch up, and then I'm gonna get like 10th again. That's okay. My record so far is 9. I just hit 3 walls. Life's going great. Ow! Oh, I should have. Oh shit! I should have taken the. Okay, that's okay. That's okay. 11. Okay. Yo, I have no faith I'm gonna be able to actually hit that. All I have. Okay, here's the thing though, right? Somebody else has to bet in order for you to get anything out of this. Otherwise, you'll just get your points returned to you. In fact, I think somebody has to bet against you. Damn, yeah. And it can't be me either. I can't just give you more channel points, unfortunately. Oh, I was trying to hit. Oh, no way! Bruh. Bro, why did that hit us at the worst possible time? Okay. This is an interesting thing to get at this position. I was expecting something that I could do more with, I think. I don't know. I feel like the piranha plant is not very versatile. Oh? Wait. Can we hit something else? Holy shit. Wait. 8. Let's go. 10 points. 10 points on the board. Chichen, it's a suck it. Dude, I'm getting to 1100 for sure. You bet against the wrong guy. Even though it probably won't matter. You'll get all your points back, but... Who do I watch on Twitch? I think my favorite people are a lot of the people in like the like OTV and Friends kind of group. I'm a particular fan of like Peter Park TV, Chris Yee, yeah, Peter Park TV and Chris Yee. They're both pretty funny, funny guys. Remind me of myself, except they're a lot more handsome. No smile. You hit me with the smile. I don't know what to do about that one. Royal Rate. Oh shit, dude, I hate this map. But maybe we can get the 4 points we need. Is it possible? You bet, right? No, dude, no way, no shot. I'm gonna hit 1100 this race. Just you wait. Just you wait. Oh shit! Oh my god, dude, how did I survive that? Oh, it's all moving so fast. Holy moly. Okay. Oh shit! Okay, well. Okay, well. Oh fuck! Oh fuck! I'm not going fast enough. I need to go faster. Alright, but now I'm off the road again. Cool, yeah, just give me the bullet bill, honestly. There's a secret shortcut in the lake. Check it out next time. Okay, yeah. If I oh my god, I used that star at such a good time. This is huge. Where? Okay, hold on. Oh shit! Such a slow motion crash. In the lake. Okay. In the lake. I don't know. I don't see it. Also, the lake is like the entire map, so I don't know. I feel like, oh my god, everybody else is very far ahead of me. Damn. I lost 1 point. Shit. Oh my god. Dude, yeah, dude, that map has like really tight corners. I don't know how to handle them. But yeah. TikTok clock is probably pretty good. Is it gonna be 200 CC for sure though? Like, I don't know, it didn't let me like choose that, you know? Maybe I should choose a glider that has less speed. I lied, sorry bro, I had to win. Oh, you were just gonna make me dunk into the lake. How do you know that I can dunk myself into the lake all on my own? Alright, dude, I need 7 points. 7 points. In like 2 or 3 races. I think it's doable. Oh god, what is this stage? Which stage is this? Wario Stadium? Wait, Wario Stadium is in this game? Oh shit! Huh, I didn't know that. Or maybe I forgot, I don't know. I probably just forgot. I actually totally... Huh. I kind of like this map in when I played Mario Kart DS. Okay, nice, I got the 2. Shit, I missed the boost. That's okay though. As long as I don't get hit by the random spinning things. Oh! Cool. Okay. Okay. Looking good. Looking good. Oh, shit. Oh my god, I almost drifted into it. Wait, I'm that close to first place? Oh shit. Okay. Okay, that guy's fucking invisible. Cool. Okay, that hit me still. Fuck. Okay, I'm all the way back in 10th place now. Man, this is a very volatile experience that I'm having right here. Okay, somehow I exited myself from the fucking stage. Now I'm in 11th. And very far behind. Give me a bullet bill or something, please. Okay, star, we'll take it. Oh shit! Okay, I drifted that really bad. I'm in last. I'm in last. I went from like 7th to last. Give me something good. Give me something good, please. Okay. Mushroom. No! Shit. Okay, whatever. Just bullet bill me. Please. As fast as possible. I just need to get not in the last place. Shit! Damn it! The bullet bill just exited me into the fucking wall! Why? Why? Oh, I can't keep up. That's crazy. Shit! Dude, after I got fucking 8th that first race, I was like, oh, this is so free. Pay out? What are you talking about? It's not 1 o'clock yet. Pay out or pay up? Shit. It's not 1 o'clock. There's still time. There's still time. I just need to get 8th again. That's all that needs to happen. It's so easy. Will never happen. It's a hater. Hater for sure. Alright, well, we got the course I selected. Toad Harbor? Yeah, Toad Harbor. Cool. Okay, there's 2 people in here that are like around the same level I am, so I should beat them, theoretically. 200cc is kind of hard, though. Okay, some people burned out, apparently. Okay. Not bad. Oh shit! Someone is trying to fucking kill me. Get me out of here. Holy shit, how did I get out? How am I alive? I shouldn't be alive. It hit someone above me? Oh my god. Kind of hoping one of the... Oh, fuck. Oh, fuck, I can't see. Shit, okay. Well, that's fine. I literally... I tried to steer, and it moved me, like, so far. Okay. Decent, decent. Cool, okay. I'm just glad it didn't exit me into the wall this time. Don't hit me. Don't hit me, I sort of fucking will. Okay, cool. Shit! Oh, okay. But we start. We gotta start. We gotta start. We can make this work. Okay, I didn't get an item, so I think I'm... Oh, wait. Wait, someone died behind me? Oh shit. Oh shit. Okay, okay, somebody died. Somebody died. 2 people? Okay, we got 3 points. We got 3 points. 3 points. 3 fucking points. Okay. Okay. There's still time. There's still time. There's 12 minutes. 12 fucking minutes. Oh my god, everybody's picking fucking Grumble Volcano instantly. That's so funny. Okay, who are these like 2 people that just don't pick on time? Please. Please just pick a stage. I bet all my money, bro. Don't do this to me, please. I'm sorry. I must do what has to be done. I mean, I still need to get 7 points and not lose any points, so... I mean... anyone's game, really. Well, we probably got time for like 3 more races, including this one. Alright, there it is. Grumble Volcano. Tech, hell yeah, I'll watch. I'll watch while I'm getting ready for my own stream in a couple hours. You have so many people, yo, you're hella pop. Nah, dude, I am not hella popular. What are you talking about? Nah, we're just chilling. Dude, I'm trying to fucking... Okay, right now I'm ranked 1093. And if I'm able to hit fucking 1100 by the time or by 1 p.m. EST, then my boy Chichen Itza here has to pay up. However, the problem is that I'm kind of bad at this game, and it's looking more and more like that's not gonna happen. Oh shit! Okay. Oh god, that boost saved my ass. Okay. Oh shit! Okay. Not bad. Oh, don't hit me, please. Oh god. Okay. You went past me. Okay. Cool. We'll just bullet bill. Maybe until like 8th or something. That would be nice. No, please. Damn it. Why do the bullet bills hurt me so? It exited me right onto the fucking lava or whatever, dude. No. Oh no. Oh right, there's Mario Kart rank. Yeah. Never say that. Oh shit. Okay. Not good. Oh. Woo. I'm alive. I missed the items. Shit. I need items. I need to get the items. Where are items? Here are items. I found items. Give me something, please. Just anything. Whoa. Oh, I thought that was like a skip or something for sure. Or was it? Wait, was that a skip? Like, I technically it made use of the Wakidu, but... 8? Oh! Yo, let's fucking go! Pay the fuck up. Yeah, of course I hit 1100. Nice job, bro. I always believed in you. Well, then you woulda guessed 1 instead of 2. Yeah. Look at that. Nobody thought this would happen. I can't believe it. But I think it probably... Wait, the bet went through... Wait. Who did it give the money to? Wait, who did it give the points to? It just took away your points. Oh, that's so funny. Okay, wait. Get me out of here. That's so funny. It just took away your points and gave them to no one. Sucks up your challenge. Dude, actually. That's so funny. Oh my gosh. Well, we'll close that. How do I make this go away? Oh, I don't. Where's that Okay. How do I turn off the music? How do I stop? How do I stop Mario Kart? Oh, God. Oh, that was quite interesting. Oh, it's just gambling. You put in points and you lose it all, or you get more from it. Your board made it to 1100. Yes, sir, dude. I like literally. I just queued up in the regional queue or whatever, and like randomly, I got put in a lobby with a bunch of people that were like 20,000 points plus, and I started at I think it was like 1069 points. So very large increase there. I don't know. Somehow I got enough eighths and sevenths and ninths and whatever so that um I was able to rank up a little bit. but um but yeah, that's it for stream today. Um got some OS stuff in, got some Mario Kart in. Tech, I'm really sorry. I misread your wow, the queuing. Yeah, it's kind of weird. I don't know what happened. But yeah, Tech, I'm sorry. I misread your announcement. I thought we were playing at 12 EST, but it was actually 12 PST. So that's on me. My bad. But I'll definitely try to make it to the next one. It's just that I have a meeting at 3:30. Um, so I can't really. I don't think I can really make it. Yeah. Do I watch NMP all? I've watched some of his clips. I haven't actually watched any of his stream content. But don't worry, you're good. We'll make another lobby. Yeah, for sure, absolutely. Um, but yeah, okay. Let's find somebody to raid. Who can we raid? I actually don't have anybody online. You guys have anybody you want to raid? Yeah, I got to. I'm busy for most of the later day too. Honestly, a social game would be fun, like Scribble or Gartic or Jackbox. Yeah, I actually have I have access to a lot of to Jackbox games, so maybe we can do something like that. But yeah. Oh, let me check. Yeah, go for it. Honestly, I was just kind of looking the software and game development area, or maybe I should look in Mario Kart since that's the last thing I was. Who should I send you guys to? Let's see. You have a friend that's streaming right now? Oh yeah, sure. Hit me up. Who is it? What's the name? Say playing in my second content team. Oh, interesting. Share screen to see the people. Oh, yeah. Just share the name of your friend. I'll raid them. As soon as I make sure that it's okay. In a Galaxy Girl 007. Okay, sure. Bet. Oh, ads! No! Why are there ads? I hate ads. Make the ads go. Oh, did he just eat a carrot? Interesting. Oh, is this like a... Just watching like a... Okay, I probably won't raid this if it's a sleeping stream. Let's just go back to Mario Kart 8 then. Can't believe you stole all my money, but it's cool. Hey, you'll make it back. I believe in you. I don't even know what she's doing. Fair enough. Yeah. All right. Let's try. I don't know whose overlay is like speaking to you right now? What are you feeling? Oh look, it's me. I'm right there. My bad. I just saw it on my watch list. Oh yeah, no worries, no worries. Um, hmm. I'm kind of liking this overlay right here, to be honest. Mr. Streamer, we can't see this. Wait, oh shit! Ah, that's cringe. I had the wrong thing in my I use studio mode in OBS and I had the wrong thing selected as my anyways, yes. Um yes. I was thinking this person because they have a neat little overlay going on. Um but I'm not sure. There we go. Nice. What else? There's actually not that many people playing right now, which makes sense, I guess. But oh gosh, yeah. I was gonna agree. Okay, let's go for it. We'll just make sure that we're actually talking.
Time zones. Duh. Jesus is a song.
Interesting.
Wow, this song is so bussin', bro. Oh, whoa. Who dis? New phone. I love saying that even if I know who they are.
Okay, you know what?
Them, I'll be like, hello.
Just for the culture, we have to. That's so funny.
It's so funny. I don't know why. I don't know why it's. So
he said, man, this music bustin', bro.
Who dis?
No fucking way,
Bro,
dude.
someone stole my mushroom. Kind of cringe of them.
All right. Well, I'll see you guys over at Largest Bread for a little bit then.
Okay, they didn't time their red shells. Luckily,
we'll see. We'll see how this goes. Yo. All right. For everybody that watched our coding stream or Mario Kart, especially out to you guys, Chichen Itza Tech. Thanks for joining.
Fuck.
But otherwise, I'll see you guys around. Oh, is there a raid emote?
Monka?
There is not. Also, this man just has TV static now. There's no raid. I don't know. Just say like raid or something.
S.
I should probably make something like that.
Monka W.
But yeah, I'll do that later. But yeah, we'll see you over there. Yeah.
I don't want to use you. You're so bad.
See ya. Bye.
Jesus Christ, you're so bad. Just give me a mushroom. God, you're so useless. No one likes you. No one. Oh. Approved cargo raid. Hello. Approved